In the world of a data scientist, the most important thing you can lay your hands on is data. Now, data can be classified in all kinds of ways. You can have structured data, which means that every aspect of it can be defined and related, and all the data you have falls into the defined structure. You can have semi-structured data, which means that most of the data is well defined and related, but some of it is unstructured, and that's the next classification. Unstructured data. Unstructured data means that your data doesn't really have a definition or a relationship. So let's dig into these a little bit and make sure that we understand them. Now let's start with structured data. Structured data is probably the type of data that most people are familiar with. It's intuitively obvious. With structured data, the structure itself is created before any data is actually populated in the database. Now that structure is generally defined during the data creation process. In fact, the most common strategy for managing structured data is using tables. So think of it like this. Imagine you wanted to store information about people at a school. You'd create tables for things like courses, classrooms, professors, and students. Now, each of those tables would include fields that help define the data in that table. So for students, it might be things like name, age, grade, and so on. Now, another main characteristic of structured data is its relational model. While each object is stored within its own table in a database, each object can relate to other objects. So going back to the school example, you can say that a student is taking a particular course which is taught by a particular professor, and those are relationships. Now, with structured data, you're not just defining the structure of the data either. It's important to realize that you can, and probably should, also structure the tables that the data is stored in. Now, that can include all kinds of stuff. For example, you can set up actual relationship keys that ensure relationships cascade. That can include deletes or even inserts. So you can add checks on the data to automatically reject inputs that don't match the structure. And of course, you can set up indexes to maximize query performance. Now, one of the things you can do while you're setting up your tables is to add checks and constraints on the data being provided. For example, you could do something like add a column size. So for example, imagine you wanted to store a 3-digit country code for a table of countries. Well, that column should be 3 characters then, right? Well, with constraints and checks, you can make sure that the contents of a particular column is exactly as you want it to be. And that includes data types too. Now, structured data means knowing exactly what kind of data you have. So if that's numbers, strings, dates, booleans, or otherwise, you can configure that however you need. Now there's some gotchas to structured data though. So for example, it can be very slow to react to changes. So let's take our example of a database for a school. In that database, we have courses, classrooms, students, and professors. Well, now let's imagine that we wanted to include some additional required information about exams, past grades, and current standing. Well, that means adding new content, but it also potentially adjusts existing content. If the database is in active use, then that can be difficult to do because it's going to impact any application currently using the database. So any changes have to be managed very carefully with the application consumption in mind. Now, structured data databases often use querying languages too, and that might seem obvious, but consider what that means. It means that collecting certain information from the database necessarily means writing queries that understand that database and its structure. So changing database technologies or changing the structure of the database is difficult, and changing the database itself can impact existing queries. Now, next, let's look at semi-structured data. This type of data is becoming much more common in today's world, especially in the cloud. Semi-structured data can include a mixture of unstructured and structured data. It's most commonly referred to as NoSQL. Rather than having a tabular format for your data, you use structurable objects like JSON or XML. So imagine an XML document, though it's usually JSON. It clearly defines an object of some kind. But then you can have another XML document that defines the same type of object or even a different type of object altogether, and you can store those two files in the same database table. Now, one thing about semi-structured data is that it's non-relational. Well, strictly speaking, it means that there aren't foreign keys like there are in relational databases. But you can have implied relationships, of course. And you can probably guess that semi-structured data is less organized than structured data. Organization is done by convention and categorization, but there's no real enforcement of those strategies. Now, generally people use tags for organizing their information. Hierarchies is another strategy. Now, unstructured data is typically stored in a NoSQL database as a serialized object. That means that all parties need to agree on a serialization language. And that's why you tend to see NoSQL databases include libraries that you can use to interact with the database. That way they can control the communication of both the client and the server. Now, ultimately, once all parties agree on the serialization language, then that means that the data can be easily shared between all parties without having to really know any of the actual system details. Now finally, let's talk about unstructured data. For as long as you've used computers, tablets, or phones, you've dealt with unstructured data. Unstructured data is so omnipresent that we don't even really think of it as data. The best example of unstructured data is binary files, audio files, image files, and so on. Basically files. Basically, it's something that doesn't have clear, common properties and values. Now sure, a document has a name, a creation date, and maybe an author, but the content of that document is virtually guaranteed to be different than any other document. Same with an image, or a random DLL. And of course that means that unstructured data is non-relational. There isn't even really any implied relationship. Now, unstructured data must necessarily be stored in a system that supports unstructured data, like a file system, for example. Some unstructured data can be stored in a NoSQL system as well. Now, with unstructured data, no structure can be defined during creation. What that means is that unstructured data is typically consumed as is and rendered as given. In other words, unstructured data is almost always used in its raw format. And what that means is that the structure of the data can only truly be defined when it's read. So let's say, for example, that we have a file system. I can see that there are files in the system, and I can even tell you what some of those files are, PDFs or documents or so on. But I would have no idea how to render one of those PDFs until the point that I actually read the file itself. And that's because I can't guarantee that one PDF is like any other. Now, I've mentioned NoSQL databases a couple of times, and there are actually a few different types of NoSQL databases. There are simple key value stores that allow you to set any sort of data as a value and then provide a key to access that. Then there are document databases, and those are similar to key value stores except that the documents are much more complex and there are generally additional properties that you can provide. Then there's column databases. Now this allows data to be stored as columns rather than rows, and that flexibility can help depending on the type of data that you're using. And lastly, there's a graph database. Now, graph databases are about establishing named relationships between objects, and this allows you to query for data based on a variety of different relationship strategies. And we'll talk more about these later in the course. So what are some of the common data store models in Azure? Well, first there's the Azure SQL database. Now, this is your most common relational database. Next, there's the Azure Cosmos DB, and this is Microsoft's biggest NoSQL database. Then there's Azure Data Storage for various simple NoSQL and unstructured needs. Azure Data Lake Storage is very good for archiving. We have Azure Synapse Analytics for big data analytics and even some data warehousing. Azure Stream Analytics is great for analyzing data as it's retrieved. Azure Databricks is another very common data analytics tool, and it's especially useful for machine learning. And next there's Azure Data Factory. This is particularly useful for data transformation and movement. And finally, there's Azure HDInsight. This tool makes it quick and easy to manage large volumes of data. So let's explore each of these data services a bit more. One of the most common relational databases in Azure is the Azure SQL database. Now, Azure SQL is primarily used as a managed relational database. What this means is that the actual installation of SQL Server is managed by Microsoft in the cloud. All you have to worry about is interfacing with the database. Now, Azure SQL can be used to store both structured and unstructured data, though it's generally primarily used for structured data. Now, one of the biggest advantages of Azure SQL is that it provides online transaction processing, or OLTP. Now, what that means is that it can scale on demand along with the requests that are being made. Now, SQL Server is quite mature. It's a first-class citizen in Azure, and that means it has strong security and availability. So why Azure SQL? Why would you choose to use this database over any other? Well, one reason you'd choose Azure SQL is in cases where you have a requirement for on-demand scaling. As your database interactions increase, you'll want your database to be able to keep up with that demand, and Azure SQL can absolutely do that. You'll also want to use Azure SQL if you have a particular focus on security and availability. If you want to secure databases, tables, or even rows of data, you have quite a bit of flexibility to do that. Now, another reason to use Azure SQL is simply because it's far cheaper than any sort of on-site infrastructure that you might have. Now, remember, the actual SQL Server installation and health is managed by Microsoft. And that means that you can focus your attention on the actual use of SQL rather than also having to manage its deployment. And even though Azure SQL is managed by Microsoft, it's actually more flexible than your typical on-site SQL Server. And that's simply because you can provision and configure it in minutes. Think of what it takes to install a new SQL Server instance on-site. It's not pretty. Another reason you'd choose to use Azure SQL is because it's protected by Azure Service Level Agreements, or SLAs. Now, this gives you the confidence that the database will be functional and available at all times. Now, great. Those all sound like pretty good reasons to pick Azure SQL. But what are some of its advantages? What are the benefits of using Azure SQL? First, Azure SQL has reliable performance because it's backed by the Azure cloud, so it always has the necessary compute power and memory to do the job. It's not dependent on a single server, so it's highly scalable and highly available. And as I said before, no administrator is required. Microsoft handles all the provisioning and maintenance for you. All you have to do is connect to the database and interact with your data however you see fit. And isn't that the point? Why waste so much time on activities completely unrelated to the task at hand? And of course, because Azure SQL is backed by Azure itself, it means that it can boast dynamic scaling. As more load is applied to the system, Azure SQL can automatically adjust and scale up to meet that demand. Now, another advantage of Azure SQL is that it has virtually no downtime. Now, while Microsoft will never commit to 100% uptime, Azure SQL is so solid that it may as well be 100%. Azure SQL has built-in intelligent optimization, and that means that stored data can be indexed automatically and stored efficiently based on typical queries and activities. It also means that various settings within Azure SQL can be automatically tuned for performance based on your use. Now, Azure SQL can also be scaled globally across regions. And that means that data can be replicated automatically to other regions to make data access in those regions quicker. And the last advantage of Azure SQL that I'll mention is the advanced security capabilities. You can secure your data however you want. Now, this can be at the database layer, the table layer, the row layer, and on and on and on. Now, working with data from Azure SQL databases is naturally very common. There are lots of options available to you. Of course, there are a huge variety of software development kits or SDKs that you can use, and those SDKs can be implemented in virtually any programming language, from .NET to Python to Java and even Node.js. For example, in .NET, you can integrate SQL using common packages like Entity Framework, or you can even roll your own solution. All you need from Azure SQL is a connection string. Now, once you've established a connection, virtually all activity is through Transact SQL, or TSQL. So simple create, select, update, and delete commands rule the day. Now, you can also use Azure Data Factory to integrate with your SQL database, and this allows you to manage the actual movement and transformation of your data. And we'll talk about that more later on in the course. Now, earlier I mentioned the flexibility of security options in Azure SQL. Now, one security feature is Advanced Threat Protection, or ATP. This allows you to keep your data safe by detecting anomalous activities. And of course, SQL includes strong encryption mechanisms that make sure that your data is safe, both in transit and at rest. Now, you can also implement SQL database auditing, which will track the various actions taken in the database and write them to the audit log for your review and consumption later on. Multi-factor authentication is extremely common these days to make sure that the person logging into the database is truly who they say they are. And you also have the ability to integrate Azure Active Directory or Azure AD authentication into the mix. In other words, you need to be authenticated with Azure AD in order to access the database at all. And finally, Azure SQL includes many different compliance certifications. Microsoft wants their product to be used by everyone globally, right? Well, that means that they have to be compliant with virtually every certification out there. Now, that means that you get to take advantage of all of their hard work. In other words, if you use Azure SQL, you can automatically say that you're compliant with a wide array of certifications. Azure Cosmos DB is one of Microsoft's most popular databases. It's very verbose and useful in just about any situation. Now, one of the biggest features of Cosmos DB is that it's globally distributed. So you can have your data replicated all over the world, and that can make queries faster in specific regions on Earth, along with making sure that your data is never going to be lost. And Cosmos DB is also a multi-model database. Now, what does that mean? Well, it means that there's lots of different API models that you can deploy with Cosmos DB. In other words, there are several different implementations that you can use to fit your specific purposes. Now, at the end of the day, data in Cosmos DB is effectively always the same kind of object. With Cosmos DB, how you interact with your data is what matters. So depending on what you want to do with the data, you need to deploy the appropriate API model. Now, one of the most popular APIs, in fact, it's the default API, is the SQL API. Now, this provides you with a more traditional NoSQL JSON document view, which you can query using a familiar SQL syntax. Now, the MongoDB API allows you to interact with your data using the MongoDB protocols. Now, you're still using Cosmos DB, but for all intents and purposes, it will seem like you're using an actual MongoDB NoSQL database. Now, the Gremlin API is fantastic for modeling your data in a graph format. You can define all sorts of vectors, the objects, and edges, their relationships. In fact, this is so powerful that Microsoft uses it themselves to handle most of their role-based access control. Then there's the Table API. Now, this is a very simple API that allows you to interact with your data as a very simple set of JSON documents. All you need to do is provide a primary key and a row key for each of your documents so that they can be uniquely identified. After that, you can store whatever JSON document you want. And lastly, there's the Cassandra API. Now, this API makes it possible to query your data using the Cassandra Query Language, or CQL. Now, just like the MongoDB API, your data will look and behave just like a Cassandra system. So why Azure Cosmos DB? Why would you choose to use this database over any other? Well, first you would choose Cosmos DB if you have a requirement for NoSQL, or at least if your project requirements are satisfied by using a NoSQL system. You'd also choose Cosmos DB if you have a focus on global scale. Cosmos DB is one of the more core features of Azure, and so it's readily available in just about every data center in the world. And one of the biggest reasons to choose Cosmos DB over any other database is if you have a need for low latency. With global deployment and the ability to replicate your data to as many regions as you want, your data is never too far away, and therefore your latency is lower. Now great, those all sound like pretty good reasons to pick Cosmos DB. But what are some of its advantages? What are the benefits of using Cosmos DB? Well, thanks to its globalization and deployment to tons of different data centers, Cosmos DB is able to boast a 5 nines uptime. And that's pretty amazing. To put that into context, it means that Microsoft is committing to no more than around 5 minutes of unplanned downtime, 5 minutes per year. And of course, you can choose what Cosmos DB will do in the event of any issue with that database. So if you have your data replicated everywhere, you probably won't notice if a system goes down. But you may have requirements that your data stays within a particular region. So for example, I've had Chinese customers that state that very clearly their data is not allowed to leave the country. Now with Cosmos DB, you can still have failover to other data centers within a region if you want, and that'd be a regional failover. Or you can just let Cosmos DB do its own automatic failover. In fact, that's what I do all the time. I just want my data. I'll let Azure decide how and where to fail over the data. I won't configure that unless I have specific requirements. But it's nice to know that I have the option. Now, another advantage of Cosmos DB is its speed. If you make a request, you will get a response in less than 1 second. Cosmos DB can achieve that by using asynchronous requests and giving you back status APIs for you to check on long-running activities. But the point is that you will always get a response quickly. But that doesn't mean that the operations are slow and that Cosmos DB is cheating by giving you these asynchronous responses. In fact, Cosmos DB guarantees 10 millisecond read-write operations. Now that's actually what you pay for. You pay for a certain amount of guaranteed throughput. So you tell Cosmos DB that you plan to read or write X amount of data per second, and it will guarantee the throughput for that load. But it's important to realize that if you go over that limit, Cosmos DB will throttle you. And if you go under the limit, then you're paying for more throughput than you actually need. So you really do need to understand your query patterns and your data models so that you can have enough throughput, but not pay so much. Now, in Azure Cosmos DB, you configure whatever consistency level makes sense to you. Now, this will be very important if you have replication enabled. The stronger the consistency, the more latency and lower availability. But the more consistent your data will be across regions. Now, the weaker your consistency, the lower your latency and higher your availability, but the less guarantees that your data will be the same in every region. So the strong consistency is effectively guaranteeing that all of your data will be in each region at the same time. A consumer will never see uncommitted data or partial writes. In other words, consumers are guaranteed to be able to read the latest committed write. Now, session consistency is similar to the strong consistency, except that it's only guaranteed in the same region. Now, outside the region, consistency is no longer guaranteed. And if a consumer attempts to read data, it may not actually get the most recent data outside of that local region. And then there's the consistent prefix option. This consistency option guarantees that your reads are never seen out of order, but doesn't guarantee their performance. So you'll definitely get the latest data that the database knows about, and you'll definitely get it in the right order, but it won't necessarily be the most recent actual data. Bounded staleness consistency is closer to the strong consistency. Now with this consistency, reads are guaranteed to be in order, but they have a certain amount of staleness to them. The difference between bounded staleness and the consistent prefix option that we talked about is that you can configure the staleness. And lastly, we have eventual consistency. Eventual consistency only makes one guarantee. All your data will eventually be replicated. Now, there is no guarantee of order, and all it's saying is that your data will eventually find its way to all the replicated databases. But that's it. So what are some of the ways that you can interact with Azure Cosmos DB? Well, one way is to wire up Azure Data Factory. Now that'll let you flow and manipulate your data right into your database. And of course, there's the Azure Cosmos DB API itself, and that will let you use just about any programming language you want, so Python, .NET, or others. In fact, you can even use PowerShell or Postman to interact with your database through this API. All you have to remember is that the data stored in Cosmos DB is managed using JSON. But if you don't want to program anything, you can actually use the Data Explorer built right into the Cosmos DB and perform some direct editing. It's pretty easy and intuitive. You can configure your settings, play with your data, and even visualize any model that you've created. Now lastly, it's worth just quickly going over the security in Azure Cosmos DB. First of all data is automatically encrypted. This is both encryption at rest as well as encryption in transit. Your data is safe. Now you can go further than that, of course. In fact, you can even set up an IP firewall to make sure that only certain IPs can access the database. And virtual networks is another option to even further isolate the Cosmos DB to just a certain subset of resources in Azure. And of course, all user authentication and access is token-based, so not just anyone can get to it. It's not anonymous. And like any other resource in Azure, Cosmos DB also supports role-based security backed by Azure Active Directory. So there's really no way that anyone without express permissions can access your Cosmos DB. And finally, Azure Cosmos DB includes many different compliance certifications. Again, Microsoft wants their product to be used by everyone globally, and that means that they have to be compliant with virtually every certification that's out there, which means that you can take advantage of all of their hard work. So in other words, just like Azure SQL, if you use the Azure Cosmos DB, you can automatically say that you're compliant with a wide array of certifications. Probably the most common data storage option in Azure is Azure Data Storage. Now, Azure Data Storage, or often just referred to as Azure Storage Accounts, are the most basic data storage option in Azure. They're no frills, straight up storage, period. Now, even though they're super basic, storage accounts are still nevertheless actually very scalable. Now, I've used these a ton of times and I've stored billions and billions of values without any issue at all. Now, Azure storage accounts can also be used as a store for reliable messaging, and that's super useful because queues can help you create completely independent systems that are simply connected just by messages being passed around. But more often than not, the most common implementation of an Azure storage account is to be used as a NoSQL store. Now, Azure storage accounts actually come in 4 different flavors, or more accurately, there are 4 different configurations that you can implement. You can also implement any combinations of these configurations if you wish. Now, the most common implementation of Azure storage accounts are blobs. Blobs are blobs of data. Think of something like a JSON file. It can contain anything you want, right? Well, you can store that JSON as an object in the storage account along with some metadata and access it however you wish. But be careful, while blobs seem like files, they really aren't. They're blobs of data. But if you wanted to store files, well, you can do that with storage accounts too. With storage accounts, you can set up as many containers as you want and store whatever types of files you want. It's sort of a poor man's SharePoint. And remember earlier when I said that you can use storage accounts for messaging? Well, you can do that by making use of the queue configuration for storage accounts. With a queue, you can add messages and other services can simply listen for those messages just like events. And finally, there's tables. Tables are like blobs in that you can put whatever data you want in there, but they're indexed through a set of keys and treated more like tabular data, even though it's still NoSQL. I use tables all the time. Alright, so why would we choose to use Azure storage accounts? One reason you'd use a storage account is if your primary need is to store data versus query it. Now let me be clear about that. Of course you're going to want to query your data, but the type of query is important. For example, if you wanted to store a list of widgets and the only way that you'd search for that data is by their identifier, then storage accounts are great. But if you want to perform queries like find all the widgets that are less than X dollars and made by a certain material, then that complexity of that query makes storage accounts not a great choice. But storage accounts are a great choice if you're working with a lot of unstructured data. This generally includes files like videos, images, documents, and so on. And one more reason that you'd choose storage accounts is when you need a cost-effective storage solution. Because storage accounts are no frills, they're also really cheap. You can store hundreds of thousands of bits of data and spend pennies per month. In fact, that's been my primary reason for using storage accounts myself. So what are some of the advantages of using Azure storage accounts? What makes it worth our time? Well, one great advantage is that it's scalable and highly available. Now, as I said before, I can put billions and billions of values in there, and storage accounts won't bat an eye. If I go looking for data, I'm virtually assured by Microsoft that the service will be running. So I pretty much never have to worry about downtime. And like most Azure services, the actual hardware and software behind the scenes of storage accounts is managed by Microsoft. They perform the system maintenance and tasks and upgrades, and all I have to do is connect to the database and use it. And that's great news because it allows you to focus on your company's value add rather than keeping the back-end system up and running. Now, another huge advantage of storage accounts is that they can be interacted with using REST APIs and SDKs. And that's important because it takes all the repetitive work out of talking to the database. Call the API, let it do the work of connecting, caching, and organizing the data, and all you have to do is serialize and deserialize your data, and you're good to go. And since you can interact with the database using an API, that leaves you free to use just about any programming language that you're comfortable with. There are even SDKs for multiple different languages. So whether that's .NET, Python, Node.js, PHP, Ruby, or Go, you're virtually guaranteed to be able to interact with a storage account. And even if you don't want or need to create a whole program, you can do simple scripting against a storage account using Azure PowerShell and Azure CLI. Simple plugins can let you interact with your storage account without ever actually having to create a program. So what are some of the ways that you can interact with Azure storage accounts? Well, one way is to use Microsoft's AZ Copy tool. Now, AZ Copy allows you to copy data from different systems. So if you want to move data from one system to another, one storage account to another, you can use AZ Copy to do that. Another way to interact with storage accounts is to wire up Azure Data Factory, and that'll let you flow and manipulate your data right into your database. And we already talked about PowerShell as an option too. You can use PowerShell to connect to your storage account and run commands to manage containers, set up access control, generate keys, manage tables and queues, and even manipulate the data in the account. Another cool way to interact with storage accounts is Storage Explorer, and there's actually two versions of this. One is a tool that you can download to your computer so you can connect to all your different storage accounts, and another is built right into the Azure web portal so you can explore individual storage accounts. Both are extremely handy and intuitive, and I use this tool all the time to explore my data and even manipulate the account. And one more way to interact with storage accounts is directly via Visual Studio. So if you're a developer and you have Visual Studio installed, you can actually use built-in components to connect to Azure and explore your data. It's effectively like using Storage Explorer, except it's built into Visual Studio. Now lastly, it's worth just quickly going over the security in Azure storage accounts. Now first of all data is automatically encrypted, and this is both encryption at rest as well as encryption in transit, so your data is safe. Now with storage accounts, you can configure access to individual containers in the account, so if you wanted someone or an application to have access to one blob container but not another one, you can do that. The access control can be as precise as you want it to be, and the way you do that is through keys and shared access signatures. You can grant a key to the entire storage account, or you can provide shared access signatures to individual containers. But at the end of the day, the storage account is a resource like any other in Azure, and so its access can be controlled through Azure Resource Manager. And what that means is that like any other resource in Azure, Cosmos DB supports role-based security backed by Azure Active Directory. And so there's really no way that anyone without express permission can access your database. Choosing a database to use in Azure is largely dependent on how you plan to use that data. Now, one database that has a fairly specific use case is Azure Data Lake. But I'm getting ahead of myself here, so let's talk about what Data Lake is first. Now, there are actually two versions of Data Lake that you can use, Generation 1 or Generation 2, Gen 2. Now, one of the primary use cases of Data Lake is data archiving. So Gen 1 sticks around because customers will have lots of data archived in there, but they don't get all the fancy features of Gen 2. Now for our part, we'll talk mostly about Gen 2. Now the way Data Lake works is by going very low level, and that means that it's a Hadoop compatible data storage system. In fact, because of how low level it is, you can store virtually any data of any size or even any type of data that you want, so that can be blobs, files, or whatever. Now let's talk about that for a second. What are some of the things that you can store in Azure Data Lake, and how would you use that data once it's there? And remember, we're talking primarily about Gen 2. Now, one of the best reasons to use Data Lake is because it can store massive amounts of data. And that makes it very, very good for performing big data analytics. Now, take our current climate, for example. Imagine a scenario where you want to evaluate COVID data for patients all around the world. Now, we're talking about billions and billions of pieces of information. We're talking about petabytes of data here. Now, Data Lake is an excellent choice to house that significant volume of data. Now, Data Lake can also be used as a hierarchical file system too. So if you want to collect and archive files, then Data Lake can be an ideal place to do that. And remember that Data Lake can store just about any kind of data at all. So that includes the most simple kinds of data there is, blobs. So if you want to use Azure Data Lake as a simple NoSQL data repository, you can absolutely do that. And you can do that at incredible volumes. Now with Data Lake, the general idea is archiving. You're looking to store large volumes of data, not necessarily interact with it in real time. However, that doesn't mean that you can't interact with it in real time. In fact, Data Lake includes a performance tuning ability to help with things like big data analytics. Now, Azure Data Lake Gen 2 is one of the first data storage services that Azure implemented, and that means that it's rich in features. For example, it has virtually unlimited scaling. Data Lake is everywhere. It's in all the regions and all the systems around the world. Do you want to store petabytes of data? More? No problem. And since it's one of the early services, that means that it's also Hadoop compatible. And even though it's an early service, it still abides by all the standard current Azure resource requirements. And that means that Data Lake includes the standard access control list or ACL support. And you can also choose how and where your data redundancy will work. So if you want to keep your data redundancy local, then you can do that with zone redundant storage. Or you can allow your data to be replicated globally using geo-redundant storage. Now, Data Lake is also POSIX compliant, which can be very important to some users. And of course, knowing that it has to store so much data, Data Lake also has an optimized Azure Blob File System driver. So why use Azure Data Lake at all? Why would we choose to use this database over any other service? Well, one reason that you would choose to use Data Lake is if you have the need to handle large amounts of data. That's Data Lake's primary feature. It can store vast amounts of data. So if you find yourself in a position where you've got to store gigantic quantities of data, then Data Lake is probably the service for you. And Data Lake is also a good choice if you have a requirement for reduced compute time. Data Lake can take care of a lot of things for you. It has built-in features or easily pluggable features. Now, I mentioned big data analytics earlier, and that feature allows you to perform all kinds of calculations on all your data without having to invoke a bunch of custom compute. And one more reason to choose Data Lake would be if there's a need for a cost-effective storage solution. Data Lake is not as responsive as, say, something like Cosmos DB. However, it's way cheaper to use. So once again, depending on your particular query patterns and what you plan to do with your data, you need to choose the right database. And Data Lake is great if you want to store a lot of data and interact with it more passively. Now, once you have your data in Data Lake, there's lots of tools that you can use to interact with that data. For example, Apache Scoop can be used to transfer data between Data Lake and other Hadoop-compatible databases. And another way is using Microsoft's AZ Copy tool. AZ Copy allows you to copy data from different systems. So if you want to move data from one system to another, you can use AZ Copy to do that. And then there's Azure Data Factory. Now that's a great tool to use to help you flow and manipulate your data right into your database. And another cool way to interact with Data Lake is Storage Explorer. There's actually two versions of Storage Explorer. One's a tool that you can download to your computer and connect to all your different databases, including Data Lake. And another is built right into the Azure portal so that you can explore individual data lakes. And both are extremely handy and intuitive. And PowerShell is another option too. You can use PowerShell to connect to your data lake and run commands to manage containers, set up access control, generate keys, and even manipulate the data in your account. And one more way to interact with Data Lake is directly in Visual Studio. If you're a developer and you have Visual Studio installed, you can actually use built-in components to connect to Azure and explore your data. It's effectively like using Storage Explorer, except that it's built right into Visual Studio. Now lastly, it's worth just quickly going over the security in Azure Data Lake, specifically with Gen 2. Now first, all data is automatically encrypted. Now this is both encryption at rest as well as encryption in transit. Your data is safe in Data Lake, as it is with every database in Azure. And also, like any other resource in Azure, Data Lake supports Identity Access Management, which is backed by Azure Active Directory. And that lets you grant whatever access you want to your database. This is at the resource level, but also even as far as the data container level. Now what that means is that you have built-in role-based access control, or RBAC. And that means that you can assign users or groups specific roles that enable them to perform built-in actions. So think of the usual read, write, delete, and so on. And it's not just users and roles, but even security groups. Built-in security groups help you to assign capabilities to your various users. And that can include things like owner, reader, collaborator, and so on. And you can also go as far as you want with security, really. In fact, you can even set up IP firewalls to make sure that only certain IPs can access the database. Let's dive into another Azure Data Service option. Let's talk about Azure Synapse Analytics. Now, Azure Synapse Analytics is a data warehousing tool like any other databases that we've discussed so far, except it does more than just storage. In fact, one of its biggest capabilities is that it can perform big data analytics. And that makes Synapse very similar to Data Lake in that way. In fact, another way that Synapse is like Data Lake is that it offers unlimited scaling. What's that? You've got more data? No problem, Synapse can handle it. So in the end, Synapse is a massively scalable data warehousing system with the ability to perform analytics on all the data that you've got stored in there. But I don't want to make it sound like Azure Synapse Analytics only does one or two things. That's not quite right. Synapse has loads of features. For example, Synapse offers the capability of a single place to unify management, monitoring, and security. Now, with other tools, you need to deploy multiple different services to achieve that. Now, be careful of that. Sometimes having individual services is better because you may only need some of those capabilities. So having a service that includes more than you need can be costly and inefficient. But if you do need a one-stop shop for all these features, Synapse is definitely good. Synapse also includes data integration through the use of pipelines, so you can flow your data in and out of Synapse with relative ease. And you can also use Synapse SQL. Now that's a distributed query system that allows for data storage and data display scenarios and extends standard TSQL to allow for streaming and machine learning scenarios. Pretty cool, right? Now Apache Spark for Azure Synapse allows for seamless integration between Synapse and Apache Spark. That allows you to use Spark for other data prep, data manipulation, ELT, and machine learning needs. Synapse has virtually all the same functionality as Data Lake. It removes the traditional barriers between SQL and Spark. And one last feature worth mentioning is Synapse Studio. Synapse Studio is a user interface that allows you to interact with Synapse and manipulate the data, perform your everyday tasks, and even integrate with your CI/CD pipelines. So, what are some of the reasons to use Azure Synapse Analytics? Why use that service versus any other? Well, one reason you'd choose Synapse is if you have a need to reduce your overall processing time for data. With all the tools and features built right in, you can perform lots of different data analytics or manipulation right there in the database. You'd also choose Synapse if you have a requirement for fast delivery of business insights. Now again, with analytics being a key feature, you can very quickly implement various analyses of your entire dataset and gain insights into what the data means. All that without having to create expensive services that query, calculate, and produce data. Another reason you might want to use Synapse is if you want to use SQL pools to simplify management. Now, although pools aren't really the requirement so much as the solution, if you have a requirement of being able to handle, say, petabytes of data without having to deal with complex installations and configurations, then pools are the answer, and Synapse does that. But at the end of the day, one of the primary reasons you'd choose Synapse is if you have a need to provide different analyses on your various data. Here you have one giant bucket of data, and you want to gain various insights on that data. Not just one thing, but many things, and Synapse has your back there. Now, there are tons of advantages to using Azure Synapse Analytics too. For example, it allows for massively parallel processing, or MPP. MPP is critical in a big data world. Imagine you had petabytes of data to analyze and a few different ways to do that. Now, that's going to be time consuming and difficult. Well, with MPP, you can kick off all those analyses in parallel. Synapse also includes the ability to independently scale compute nodes. Now, for all the processing that Synapse will do, some of those processes may be more complex than others. So if one process requires more compute, then Synapse can scale appropriate nodes independently. Another advantage of Synapse is the flexibility it gives you to help improve performance. So for example, you can configure some data to be replicated between various nodes so that the data needed to perform certain operations is local to that process, and that can help speed up your system as a whole, all through configuration. And at the end of the day, Synapse is set up so that you only pay for what you use, and you're in total control of the compute power that you configure and how much of it that you're going to use. So if your instance of Synapse doesn't do anything, then you won't pay anything. If it's massively computationally complex, then you will pay for that compute power that it uses. Now, like most Azure resources, there's lots of ways that you can interact with your instance of Azure Synapse Analytics. And here are some ways that you can work with the data that you have in Synapse. First, and probably most commonly, you can extract, load, and transform your data. This is referred to as ELT. And of course you can do that. It wouldn't be much of a database if you couldn't add data, query data, and even augment data. ELT is critical to any database. But with Synapse, it can do it at massive scales. You can also use Polybase to interact with your data. In fact, Polybase removes a ton of complexity for data engineers. It's very quick and interfaces seamlessly with Synapse. And as you've probably come to expect so far in this course, Azure Data Factory can be used to connect with Synapse and flow data, as well as manipulate data on its way into Synapse. Now finally, let's talk about the common security features of Azure Synapse Analytics. First, it's worth noting that like all Azure resources, Synapse works very well with Azure Active Directory, or Azure AD. And that means being able to connect to Synapse necessarily means that you have to have an Azure AD identity to work with. Now that doesn't have to be a user per se, it's just easiest to think of it that way. Now if it is a user that you're using, then Azure AD offers the added benefit of being able to enable multi-factor authentication, or MFA. And that means that you can virtually guarantee that the user connecting to your Synapse system is who they say they are. But interaction with the database itself doesn't have to be Azure AD based. You can also use the bog standard SQL Server authentication methodology too. And since we're talking about SQL type authorization, it means that you can implement security at various levels of your database. So that can be anything from column-based security to row-based security. So when it comes to security, Azure Synapse is totally set up and good to go. The next service we'll discuss in this course is Azure Stream Analytics. Now this can be a very powerful tool, but you have to be very careful about how you use it. The main thing about Stream Analytics is that it's primarily geared towards real-time, continuous analysis of event data as it comes into your system. Effectively, Stream Analytics is used to process what we refer to as data streams. So imagine you have a data flow of some kind, like a smart thermostat taking temperature readings every few minutes. That temperature reading, or rather the collection of temperature readings over time, is called a data stream. And Stream Analytics monitors those data streams. And what does it do with those data streams? Well, it analyzes the data and identifies data anomalies. Now, those anomalies can be responded to in a variety of different ways, from basic notifications to full-fledged custom code. Now, there are lots of great uses for Azure Stream Analytics, and I've used it myself. Probably one of the most promising implementations of Stream Analytics is with IoT. You can attach Stream Analytics to your IoT hub and consume data as it comes in from your various IoT devices. And that lets you analyze and make decisions on data as it arrives into your system. And you don't have to use Stream Analytics on just data streams either. You can also use it to analyze things like web logs. And that can be very useful if you're trying to monitor the health of various services and applications in real time. In fact, that's really the key use case for Stream Analytics. If you think about it, it's all about ongoing monitoring. You can use it to do various other things, but at the end of the day, you're really using it to monitor and analyze data as it flows through your system. Now, another potential use case is to use Stream Analytics at the point of sale. Now, the point of sale is the point in any service where the user executes payment for some goods or services. Now, Stream Analytics can be used to monitor payments and exchanges to make sure that there isn't anything erroneous going on. So think of something like credit card anomalies. So why would you choose to use Stream Analytics? Why use that service versus any other? Well, you can tell from everything that I've said so far that you'd use Stream Analytics if you have a requirement for real-time responses to various conditions in the system. So for example, you could say that if a data value ever goes over some limit, you can take immediate action. And of course, that's the other reason you'd choose to use Stream Analytics. If you have a requirement to perform continuous data monitoring, you can do that with this tool. It doesn't have to necessarily be about responding to conditions. It can be just about detecting and logging those conditions. Now remember that responding could be just about performing certain additional calculations. It doesn't have to be about sending out emails or alerting the world. Monitoring data is generally for situations where you do want to know what's going on in real time. Now, Stream Analytics can also be good for streaming batch data from one system to another. So if you have the need to flow data as it enters one system to another system, Stream Analytics is a mechanism to do that. Now, one thing to be really careful about with Stream Analytics is that it can be expensive. You have to be careful about what you're implementing and how much data you're consuming and what you're doing with the results. If you're using it blindly without any thoughts for those types of things, then you may find yourself spending a lot of money for these features. Now, there are lots of different ways that you can work with data as it flows in and out of Stream Analytics. For example, Event hubs. Now, event hubs allows you to collect data in queues and distribute that data to various consumers. So Stream Analytics can be a consumer of events as it enters event hubs, as well as a contributor of data that flows into event hubs. An Azure IoT Hub is similar to event hubs, except that it's generally IoT devices that contribute data to the hub. But Stream Analytics can once again be a consumer of the data that comes into the IoT Hub. And you can also use Stream Analytics to consume data from Azure Blob Storage databases. Now think about that. As data or even files are added to a Blob Storage account, Stream Analytics can consume that event and perform various actions. Now, Stream Analytics includes input and output pipelines, and that means that you can configure how data will come in through the input pipelines and where it'll go through the output pipelines. In fact, the way Stream Analytics works is by defining jobs to do. When you set up a job, you generally set up that route for the job output, and that means that when the job executes, you're telling Stream Analytics where to route the results of the job. Now, once all the data has been processed by Stream Analytics, you then have the ability to route it to all sorts of other data stores. And what that means is that something like Stream Analytics can be an essential piece of activities like batch analytics in systems like HDInsight. And that's really the key here. While Stream Analytics can do all kinds of stuff with your data as it comes into your system, the point of doing that is to create some other data that will be consumed by other services. And those other services can be databases like we've talked about already in this course, but it's worth noting that it can also be something like Power BI. And that's an interesting use case. Imagine having data flowing into your system from an IoT device, then analyzing that data in real time and displaying the results of that real-time analysis directly on the user's desktop using Power BI. And of course, Azure Stream Analytics includes a whole host of security aspects worth knowing about. While data isn't stored by Azure Stream Analytics per se, that doesn't mean that it doesn't have security. Data flows through Stream Analytics, so it needs to be secure in transit. And it does do that. There is a secure transport layer between devices and IoT Hub and then to Stream Analytics. And once data has been streamed, it's discarded or ignored. In other words, data flows into Stream Analytics and then right back out. There is no storage at all. So there's no need to implement any data at rest security protocols. And interacting with Stream Analytics as an app or as a user still abides by Azure's general security principles. So that means that access to data flowing out of Stream Analytics requires a shared key to enable secure data transfer. If you don't have that key, then you don't get any data. And finally, just to hammer that storage point home, Stream Analytics doesn't store data, so it has no need for encryption at rest. And what that means is that data security must be provided by whatever storage device or service you're using. When we talk about data framework options in Azure, it's hard to do that without considering Azure Databricks. Now, Databricks is a serverless service from Azure, and that means that there's no need to set up virtual machines or establish compute. It's all based on services running in the cloud. And because of that, Databricks has been highly optimized for Azure. It's finely tuned for use with the Azure ecosystem so it can manage data effectively and scale as needed, all behind the scenes. Now, what that means is that Databricks offers a simple one-click setup. All you have to do is ask Azure for an instance of Databricks and off it goes. And it'll do all the heavy lifting of infrastructure and configuration. But what is Databricks? Well, Databricks is a multi-environment offering that allows you to develop data-intensive applications. And it does that in two ways. The first is through SQL Analytics, which lets you put together super efficient workflows for managing your data. And the second is with interactive and collaborative workspaces that allow data engineers and data scientists to work together in a single environment. In other words, Databricks is a data warehousing tool with advanced SQL-based analytics capabilities. And one of the other things that Databricks does is that it adds capabilities to Apache Spark. In other words, you can connect to it with Apache Spark and start making use of all sorts of features in Databricks to extend Spark. Now specifically, you can use Databricks to manage your Spark clusters. Now one thing Microsoft does really well is to put intuitive, user-friendly interfaces in front of complex systems. And Databricks is that easy-to-use interface that can help you manage your Spark instance. But don't worry, it's not just a pretty UI. If you want to get deep into the weeds, you can absolutely do that. In fact, Databricks, like most Azure resources, includes a set of REST APIs that allow you to perform all kinds of tasks through code. So if we're talking about managing clusters through the UI, well, don't worry. You can manage those clusters through REST APIs too. Now, anyone who's familiar with machine learning is going to be familiar with Jupyter Notebooks. Well, Databricks also includes a notebooks feature, and this can be hugely powerful. Remember that Databricks is a data warehousing tool with powerful query capabilities. Well, with the notebooks feature, you can also get right into the guts of your data by programming whatever scripts and logic you want using languages like R, Python, Scala, or even just plain SQL. But there's a lot more to it than that too. Whether you're using notebooks or the REST APIs or any of the other connection options in Databricks, there's a whole host of role-based security that you can implement. And that granularity of security, which is backed by Azure Active Directory, allows you to implement enterprise-grade authorization to your data. Now, Azure Databricks has a variety of other features worth talking about too. For example, Databricks includes the ability to have multiple fully managed SQL endpoints directly accessible from the cloud. Now, what that means is that you can actually run SQL queries directly against those endpoints. Now, the endpoints themselves can be configured in all sorts of different ways to account for the expected query latency, the amount of data it serves, or even just the number of users you expect to have using that endpoint. And you can also use Databricks to configure alerts that help you monitor and integrate your data. And when you set up alerts, you can be notified when any field returned by any of your queries exceeds some given threshold. And you can use alerts as part of your business practice, or you can even integrate them into other services to start other workflows. So for example, you could set up an alert to monitor certain data streams and then automatically create support tickets if those data streams exceed certain thresholds. But what good is a tool that lets you create queries and alerts without a dashboard? Well, not very good at all. And that's why Databricks includes dashboards. With the dashboarding features, you can visualize your data and share insights that you get from your queries. Now, a little bit earlier, I mentioned that Azure Databricks lets you configure enterprise-grade security against your data. But how does it do that? Well, the most important piece of the puzzle here is Azure Active Directory, or Azure AD. Like most of the resources that you can configure in Azure, Databricks integrates directly with Azure AD, and that means that you can create and manage your users using Azure AD, either in your own tenant or through a B2B relationship with your customer's tenant. Regardless, once you have these Azure identities, you can assign their access to Databricks. And that access is the usual Azure role-based access. Each user, or even groups for that matter, can be granted various levels of permissions to your resource, or even your data. Now that can include roles like owner, contributor, reader, and so on. And there are actually quite a lot of different roles that you can assign. Azure has a default deny strategy, so that means that it will default to forbidding access unless permissions are specifically granted. And Databricks can also include its own enterprise-grade scale service level agreement, or SLA. So you can choose the appropriate SLA that protects your data and your business. Now, Databricks is pretty powerful. There are actually lots of other Azure resources that integrate with it really nicely too. Now remember that Databricks can be used as a data workflow tool, and that means that it can be used to flow data from one source to another and manipulate that data along the way. So what that means is that the tools that integrate with Databricks best are the tools that accept the data flow. So for example, Databricks can flow its data to data stores like Azure Synapse Analytics for extra analytics. Of course, it can flow its data to something like Azure Data Lake too, and that's particularly good for storage, but as you know, it can also be used for additional big data analytics. But if it's just storage you want, particularly at a globally redundant scale, then you can flow your Databricks data to Azure Cosmos DB. Now just remember that Cosmos DB is really good for fast access to data, but not necessarily great for long-term storage because it can get pretty costly. So if you want another option for simple data storage, then you can flow your Databricks data to a simple Azure Blob Storage account. But it doesn't have to be just about storage or analytics either. If all you want to do is be able to visualize the data that you're querying, then you can use Databricks to flow data straight into Power BI dashboards. Now, I mentioned Databricks workspaces a couple of times so far too. But just what are workspaces anyways? Well, a workspace is an analytics platform that's actually based on Apache Spark. Databricks integrates Spark into Azure and makes the interaction with Spark seamless for collaborators like data engineers and data scientists. Apache Spark, and therefore Databricks Workspaces, includes a bunch of technologies and capabilities. For example, Spark SQL is a module in Spark for working with structured data. You can use data frames in Spark SQL to handle distributed collections of data and organize them into named columns. In effect, a data frame is like a relational database. Another feature of Databricks Workspaces is the ability to stream data, and that means that it can integrate quite nicely with tools like HDFS, Flume, or Kafka. Databricks is often integrated with machine learning too. MLib includes a set of common machine learning algorithms for models like regression, classification, and clustering. You can use GraphX to explore your data from graph modeling perspectives too, and that can be very valuable depending on how your data relates to each other. And one more feature is the Spark Core API, and that's just what it sounds like. If you want to go real deep into the weeds from a programming perspective, you can integrate with the API and go to town. Now, another thing we've mentioned a few times so far is using Databricks to manage Spark clusters. Databricks is wrapping Apache Spark, and so therefore it has to manage clusters in Spark. Databricks is extremely simple. It looks to simplify the entire process, but it doesn't mean experts can't get involved and do complex things if they need to. Regardless, Databricks makes it easy to quickly create clusters as needed. You can also configure auto-scaling, and you can do that up and down. So if you have an influx of demand, you can automatically scale up. But if the demand is low, maybe it's the middle of the night, then you can automatically scale down and have some cost savings too. Databricks also makes it so that you can share clusters across teams. And again, while everything is nice and easy, you can still go directly to APIs and program clusters as you wish. And Databricks, like any other Azure resource, takes security very seriously. So all data integration is handled securely. And what that means is that you can unify your data without centralization, and you can do so in a secure manner thanks to the enterprise-grade security. And the last thing I'll mention is that Apache Spark implementation that's managed by Databricks is automatically updated, so you don't ever have to worry about Spark itself. One of the fastest growing and most important data-related services in Azure is the Azure Data Factory. Now, Data Factory is a cloud-based integration platform for performing complex actions around extraction, loading, and transformation, or ELT. Put simply, Data Factory is really about controlling the movement of data between stores. But really, it's way more than that. Data Factory not only acts as a conduit for data to move from one location to another, but it can also be used to collect data and transform data. And at the end of the day, it's a data orchestrator. So let's dive into that a little bit. First, let's talk about how Data Factory works. First, and critically, Data Factory works by using workflows. A data scientist or a data engineer will connect to a Data Factory instance and create a data workflow. Sometimes this is referred to as a data pipeline. Now, the idea behind a data pipeline is to configure and ultimately automate the movement of data from one system to another. And these pipelines can be schedule-driven or even event-driven to happen automatically based on certain events. But these workflows aren't just about movement of data either. One of the things that you can do with a data pipeline is transformation. What that means is that you can take input data and transform it into another form before moving it to another source. So for example, imagine you wanted all the data in your system to look exactly the same. Now you want to store all your values with a simple value and a timestamp, let's say. So now imagine all the different sources of data that are out there. There's no chance that those different sources are all sending you data in the same format, let alone the format that you want it in. Well, you can use Data Factory to collect all the data and transform it to the format that you want it in, and then move it to the data source of your choice. Now, the way Data Factory works is by using a whole bunch of compute power. It's not just free processing. Depending on how complex your workflows are, Data Factory will use the appropriate amount of compute power to move and transform your data. Specifically, Data Factory uses compute from systems like Azure HDInsight, Apache Spark or Databricks, Hadoop, or even Azure Machine Learning. Once all the data is collected and transformed, workflows move data to other data stores by publishing that data. So one common use case for Data Factory is to collect data from IoT Hub, transform that data, and then publish it to a data warehouse like Azure SQL. Of course, it doesn't have to be a relational database like SQL. You could choose to publish your data to Cosmos DB or even just a simple blob storage account. Now, the point of Data Factory is really all about organizing your raw data. You have all this data formatted in all these different ways from all these different and disparate data sources. Now with Data Factory, you can reconcile all that information, transform it, and then organize it into a single, more appropriate data store. Okay, but how does Azure Data Factory work really? Like, what's the end-to-end? If you wanted to set up a workflow in Data Factory, what would you typically do? Well, to answer that, you need to consider what a workflow is. What are you trying to do with a workflow? Well, the short answer is you're trying to collect data, transform it, and then move it somewhere else, right? Well, there, you've answered the question. The first thing that any workflow will do is connect to an appropriate system and collect the data it needs. Those systems can be almost anything. They can be IoT hubs, event hubs, or just other data stores in general. And once you're connected, then you collect the data that you need from that data source. Then, once you have the data, you can transform it however you want. The goal is ultimately to enhance the data that you've collected into something more useful. That can be simply to restructure and organize the data, or it can be to add some additional insights. So for example, you may want to add some metadata about the source of the data. That way, downstream sources can know where that data ultimately came from. And once you've collected and transformed the data, you next want to publish the data. Now this is the crux of the pipeline. In fact, that's what makes it so akin to a standard software CI/CD pipeline. Your goal is to deploy the data to the appropriate location once it's reached a certain level of quality. And you can deploy that data to virtually any Azure data store you want. And of course, you'll also want to monitor your workflow. Is it running? Has it been running successfully? If your pipeline isn't running, then you're starving your system of critical data. So obviously, you'll want to know about that ASAP. Now, Azure Data Factory is a pretty rich service. To facilitate all the data movement and transformation, there are several components built into Data Factory to get you where you need to go. Of course, we've talked about pipelines. Those are the actual workflows that help define data movement and transformation. But pipelines are actually composed of smaller parts that tell the pipeline what to do. And those parts are referred to as activities. So you can have activities like copy, move, delete, transform, and so on. And you can also configure conditions as activities. So your workflow can contain just about any sort of logic you can think of. Data Factory also includes dataset components. Datasets are representations of the actual data in your reference data stores. So you can have a data store that maps to a service like Cosmos DB, and then you have a data set that maps to the actual data in the store. Another component of Data Factory is what's called a linked service. A linked service is a reference to another service that Data Factory might need to interact with. All that's needed is a connection string, and you're good to go. And data flows are exactly as they sound. With all these components put together, you'll generate a data flow. This is just another way of looking at workflows. You'll be flowing data from some source to a destination and augmenting that data along the way. And finally, integration runtime components are the actual underlying compute infrastructure used by Data Factory to provide all the capabilities that we just talked about. The last Azure data service that we'll talk about in this course is Azure HDInsight. HDInsight is a service in Azure that helps you collect, process, and analyze your data. It can be very handy because it supports actions like batch processing, data warehousing, IoT, and more. HDInsight is a pretty low-level resource in Azure, so that makes it a low-cost solution for most situations. It also wraps other technologies. Specifically, HDInsight wraps Hadoop, and that means that it includes Hive, HBase, Spark, and Kafka. Hadoop stores data physically and Spark stores data in memory, and that difference means using Spark is about 100 times faster. HDInsight also wraps HBase for NoSQL needs, and it's also built on Hadoop, so that means that the HBase configuration can offer automatic failover. And there's also a wrapping for Apache Storm, and Storm can be used for real-time stream analytics of your data. And finally, HDInsight wraps Kafka. And Kafka is what lets you manage data movement and transformation pipelines. Now, as a data scientist or a data engineer, you'll have a very specific way of working with data in Azure HDInsight. As you've seen in all the data services that we've discussed in this course, understanding your data and your query patterns is essential for understanding which service to implement and how to implement it. And HDInsight is no different. If your goal is data movement, as in you want to extract, load, and transform your data, or ELT, then you'll want to implement Hive. Hive is the ideal choice for HDInsights for performing whatever ELT operations you have. Now, as an alternative, you can actually use Azure Data Factory to orchestrate your Hive queries for you. What that means is that you'd set up HDInsights, set up Hive, and then implement an instance of Data Factory to manage the data movement. So why use Azure HDInsights? What are some of the reasons that we choose to use the data service? Well, one reason is that it's cloud native. And that means that it's not a lifted service that's running on managed virtual machines. It's a legitimate cloud service that has all the benefits of being a cloud service. Specifically, scalability and cost. By running as a set of distributed microservices rather than a bulky VM-based solution, HDInsights scales very well and minimizes its compute footprint. Now, HDInsights also integrates very well with other Azure resources. For example, you can connect it to Azure Monitoring and automatically watch the health of your clusters. Now that integration with other resources means increased productivity too. And that's simply because it enables you to use the right tool for the job. So if you want to use another tool for visualization, then you can do that. HDInsight is an extensible tool too. So you can install additional components on all the various clusters by using simple script actions. And that enables seamless integration with other popular big data solutions with a simple click. And of course, since HDInsight is an Azure native service, it abides by all the standard security and compliance rules of Azure. And last but not least, another reason to use HDInsight is that it's globally available. You can deploy it to any region. Now, HDInsight is easily integrated with too. There's lots of different ways to work with data in Azure HDInsight. You can use Java, Python, or other programming languages to process your data. You can use a tool like Mapper to consume and analyze your input data. In fact, Mapper produces data tuples that can then be fed into Reducer to analyze further and create summaries on. And if you want, you can use Spark to process streams. And if it's machine learning that you're interested in, HDInsight includes around 200 preloaded Anaconda libraries that can be integrated with Python. And you can also use GraphX for graph-based computations against your data. And finally, you could submit and monitor jobs using Storm. Storm also supports various common programming languages like Java, C#, and Python. And lastly, let's talk about security in Azure HDInsight. First, it's important to understand the encryption mechanism in HDInsight. Your data is secured through standard Azure encryption methodologies. So any data stored is encrypted at rest, and all data that's moved around is encrypted in transit. So no one can sniff your data or connect to your database. There are several ways to get at that data though, and all of them are secure. One of the ways is using Hadoop's Secure Shell, or SSH. Azure can generate that connection for you, and that connection will be guaranteed to be secure. If it's the applications that need to connect to HDInsight and interact with the data, then they can use shared access signatures. No application will be allowed to perform any action with your data without a shared access signature. In fact, you can create separate signatures for each application, each with different permissions. So you can control access with as much granularity as you want. And of course, all access to everything in Azure is backed by Azure Active Directory. So in this course, we've examined Azure Data Platform Services. We did this by exploring Azure data structure types and the Azure SQL database, Azure Cosmos DB and Azure Data Storage, features of Azure Data Lake Storage Gen 2 and when to use it, data warehousing and big data analytics and the Azure Synapse Analytics platform, processing streaming data with Azure Stream Analytics, features of Azure Databricks, Azure Data Factory, and Azure HDInsight. In our next course, we'll move on to examine Azure Storage Account options.